Hi there, welcome to this warm-up review. Let's get started. First question. What rectal diseases are found proximal to the pectinate line, and what diseases are found distal to the pectinate line? So proximal to the pectinate line, you can see adenocarcinoma. So we're talking here about colorectal cancer and then also internal hemorrhoids. And then distal to the line, you can see squamous cell carcinoma, which would be anal cancer, and also external hemorrhoids. Next question. Which antihypertensive drug has each of the following side effects? So first would be first dose orthostatic hypotension. So these are your alpha-1 blockers or your Zosyn drugs. Next would be hypertrichosis. This is minoxidil. That's easy because minoxidil is Rogaine. Next would be cyanide toxicity. This is nitroprusside. And then finally, dry mouth, sedation with severe rebound hypertension. Clonidine is well known to do this. Next question. During a high school football game, a young athlete collapses and dies immediately. Which type of cardiac disease should be suspected? So the most common cause of this would be hypertrophic cardiomyopathy. Alright, that's it for this warm-up review. Let's move on to the lecture.
Hi, welcome back. Now let's talk stats. First, we're going to talk about statistical distribution. This is definitely an important concept, at least a 4-star topic. I would expect you to have a question about this. So right up front, let's talk about a few statistical terms, specifically mean, median, and mode. Mean is the average of all the values. The median is the value that falls right in the middle of all the values, where half of the values fall above it and half the values will fall below it. And the mode is the value that occurs most commonly. So as you can see from their definitions, these values may be very different from one another on some distribution curves. However, when you're talking about a normal distribution, also known as Gaussian or bell-shaped distribution, what you find is that the mean is equal to the median is equal to the mode. But I want you to remember that the mean equals median equals mode only happens with a normal distribution, where the distribution of values follows a perfect bell curve. Obviously, this is a rare occurrence. There is usually some variation of distribution occurring. One variation is called a bimodal distribution, where the values form two humps. So a bimodal distribution has two humps or two modes that provide a visual clue that the study participants are falling into two different groups. If you're studying a drug and the study results show a bimodal distribution, you might be looking at one group where the drug is effective and one group where the drug is not effective. If you're looking at a lab result, you might be looking at one group where the lab result is positive and one group where the lab result is negative. If you're looking at test scores, you might be looking at one group who actually attended all of the classes and understood the information, and the other group who didn't attend all of their classes and didn't get the information. So you have two main categories or groups of people. Another way that the distribution curve can vary from the perfect bell curve is that it can be skewed. Now, I want you to remember what I'm saying here about a skewed curve. A positive skew is where the distribution curve is asymmetric and has a tail to the right of the curve. In this situation, the mean is greater than the median, which is greater than the mode. It may help you to think of an amoeba sort of moving in the positive direction. So this is a positive skew. A negative skew is found with an asymmetric curve with the tail on the left. With a negative skew, the mean is less than the median, which is less than the mode. Again, a negative skew has a tail to the left. This is pretty simple stuff, and it's important to know for step 1. So be sure that you can recognize a positive and a negative skew and know the difference between mean, median, and mode. All right, now let's move on to statistical hypotheses. Statistical hypotheses, error types, and power are all high-yield topics. We would give this information 5 stars, really important for step 1. You'll probably have 2 or 3 questions on this stuff, so try to really take in this information. Now let's begin this section by talking about why we would even perform a scientific study. Well, usually what happens is that someone makes an observation and forms a hypothesis, but they don't know if their hypothesis reflects reality. They don't know if the drug in question has real benefit or if a certain exposure is truly a risk factor for disease. So studies are performed to try to discover true effects of exposures and interventions. Unfortunately, studies have bias and error, many different kinds of bias and error, so they don't always reflect reality. And this is why it's important that we understand study design and study error so that we can critically evaluate scientific studies and determine how well they reflect truth. One way to evaluate test results and how well they reflect truth is through hypothesis testing. The first step in hypothesis testing is outlining the null hypothesis and the alternative hypothesis. The null hypothesis, which is designated by a capital H and a subscript 0, or H naught, states that there's no association between the exposure and the outcome or disease. In other words, the null hypothesis is just saying that something is not related to something else. On the other hand, the alternative hypothesis, designated by a capital H and a subscript 1, or H1, states that there is indeed an association between the exposure and the outcome or disease of interest. The original assumption in hypothesis testing is that the null hypothesis is true. Therefore, it is left to the investigator to reject the null hypothesis using the study data. So after outlining the null and alternative hypothesis and acquiring the study data, the investigator then analyzes the data and judges the compatibility of the study data with the null hypothesis. The type of statistical test used by the investigator depends on what type of data were acquired in the study, and we'll discuss some possible statistical tests later. But suffice it to say that the p-value is the value of interest at this point in hypothesis testing. The p-value lets us know how compatible the study data are with the null hypothesis. So a very small p-value indicates that it's very unlikely that the study values occurred as a result of chance alone. So very small p-values are not compatible with the null hypothesis. With a very small p-value, you cannot say that there's no association between the exposure and the outcome of interest, and that all of those observed results were merely due to chance. This then leads us to the third step of hypothesis testing, which is when the investigator decides whether he can reject the null hypothesis. In most studies, the investigator chooses a value of 0.05 as the p-value cutoff for determining whether or not it's reasonable to reject the null hypothesis. If the p-value is less than 0.05, the investigator will usually conclude that it's not reasonable to assume that the null hypothesis is true. So they formally reject the null hypothesis and accept the alternative hypothesis that indeed there is an association between the exposure and the outcome of interest. Now, let's discuss error types that are associated with hypothesis testing. We'll be discussing type 1 error, also known as alpha error, and type 2 error, also known as beta error. Type 1 error occurs when the investigator rejects the null hypothesis and accepts the alternative hypothesis, when in reality there is no association between the exposure and the outcome. So it might help you to think of this as a false positive error because the investigator said there was an association when there really wasn't. A type 2 error occurs when the investigator accepts the null hypothesis that there is no association between the exposure and the outcome, when in reality there is an association. It might help you to remember this as a false negative error because the investigator said there was not an association when in reality there was. Say you were doing a study that was looking at smoking as a risk factor for lung cancer. If your data analysis gave you a p-value of 0.1, you might accept the null hypothesis and say that there's no association between smoking and lung cancer. This would be an example of type 2 or beta error. One way to visualize this information, which might help you remember it, is to put it into a 2x2 table. Across the x-axis is written reality, wherein you put the values that reflect the true state of the situation. The two columns are labeled H1 and H0. Then along the y-axis is written study results. The two rows are labeled H1 and H0. In the top right box, you can fill in alpha. This is where a type 1 error or alpha error would occur. That is, when the study analysis shows an association between the exposure and the outcome, but the reality is that the association does not exist. Now, you would fill in a beta into the bottom left box. This is where a type 2 or a beta error would occur. That is, when a study analysis does not show an association between the exposure and the outcome, when in reality an association does exist. In the top left corner, you would fill in the word power, or 1 minus beta, because the power of the test is equal to 1 minus the probability of the type 2 error. We'll discuss more about power in just a few minutes. But first, let's talk about the p-value. What is p? Well, like I already mentioned, the p-value lets us know how compatible the study data are with the null hypothesis. In other words, if the p-value is high, it supports the null hypothesis. If the p-value is very low, it does not support the null hypothesis. How do we judge if the p-value is high or low? Well, we use a cutoff value called the alpha level. Now, the alpha value is set by the investigator prior to the beginning of the study as a measure against which the p-value is judged. In medical studies, an alpha value of 0.05 is usually used. It's an arbitrary number chosen by the investigator, and it could be some other number, but the convention in medicine is that an alpha value of 0.05 is good, and most of us are comfortable with this cutoff. Now, the p-value is calculated from the data set, and then that calculated p-value is compared with the chosen alpha value of 0.05. If the p-value is less than that cutoff value of 0.05, then the null hypothesis is rejected, the alternative hypothesis is accepted, and the results are usually designated statistically significant. Now, if the p-value is greater than 0.05, then the null hypothesis is not rejected, and the results are said to be not significant. Just so you know, this p-value stuff is pretty important. So be sure to remember what the p-value represents and how it's used to determine the significance of study results. Okay, now let's talk a little bit about power. Power refers to the probability that a test will correctly reject the null hypothesis when it's indeed false and the alternative hypothesis is true. What affects power? Well, there are many variables involved, but there are a few that are intuitive. The investigator needs to know what the expected outcomes are in the control group and the magnitude of effect that they expect to see in the experimental group. So if they expect that the magnitude of effect resulting from an intervention is going to be very small, they're going to need more participants in order to convincingly demonstrate that difference. If the magnitude of effect is expected to be very large, then the investigators can include fewer participants to adequately show an effect and thereby allow for the rejection of the null hypothesis. If the investigator expects a lot of people to drop out of the study or be non-compliant because of side effects, then this also needs to be taken into account when trying to power a study correctly. By increasing the number of study participants, the investigator can increase the power of the study. The more people that are included in the study, the more likely the results will reflect reality. However, with additional study participants comes increased expense, increased time, and more effort. So there needs to be a balance. In my medical school class, there was a bunch of guys involved in a research study of the lipid effects associated with drinking wine versus grape juice. And they were all in the grape juice arm, and they were drinking liters of grape juice every day. And of course, they all developed terrible diarrhea, and they all dropped out of the study. So I hope that investigator knew to increase the number of participants in order to account for participants dropping out. That grape juice study always comes to my mind when I'm thinking about how to power a study. I sure hope that investigator knew what they were doing. All right, complex stuff, but very high yield. And there's just one more video on statistics, so we're almost there. For now, go ahead and pause your video, go through the end of session quiz, and then turn your video back on so we can go through the answers together. All right, let's get started. First question. Study X shows that vitamin C can prevent coronavirus infections, but 10 other studies show no benefit. What type of error is found in Study X? Well, this is type 1 error or alpha error. You're finding an effect that does not really exist. Okay, next. Study Y shows that aspirin administration during an MI offers no improvement in patient morbidity or mortality. What type of error is present? Well, this is a type 2 error or a beta error. You're finding no effect or no difference when in fact an effect does exist. Next, what's the difference between the mean, the median, and the mode? Remember, mean is what we usually call the average, where we add up all the values and then divide by the number of values. Median is that middle value, taking into consideration the frequency of the distribution so that half of the values are above the median and half the values are below the median. And then the mode is the most frequent value, the one that turns up most frequently. Next, what does it mean to say that a statistical distribution has a positive skew? Well, a positive skew means that instead of a normal Gaussian distribution, the curve is shifted to the left with a tail to the right, so that the mean is greater than the median, which is greater than the mode. And that's the end of our end of session quiz. That's the end of our lecture on statistical distribution and error. I'll see you next time.